what is the gradient of this function at the point 2 and 4? To answer this question, you need to know what a gradient is as a start. I think that's a I think that's a good starting point. The gradient is just the higher dimensional derivative you could think of. In fact, if you have a function that only has one variable, then it gives you the total derivative. It gives you the derivative of the function. So this is more or less a generalization in a sense. Well, not a complete generalization, but nevertheless. I mean, this is not the time to voice my opinions regarding this very specific object. So let's get over that. The gradient is the vector which holds all the partial derivatives of f. By all partial derivatives, I mean all partial derivatives with respect to each variable. Here we have two variables, so we would have two partials, one with respect to x and one with respect to y. And then we would evaluate it at 2 and 4. Let's take a look. So the gradient of f in our case is going to be partial f partial x, then partial f partial y. It seems that the order matters. So we follow the order in which the variables are listed. What is the partial derivative with respect to x of this function? You fix y, so you treat y as some constant, and you take the derivative of x, or 1 over x. The derivative of 1 over x is minus 1 over x squared. Now, if you want to do the same thing here, treat 1 over x as a constant, and you take the derivative of y squared with respect to y. Now, the derivative of y squared with respect to y is just 2y. That's not too difficult. And then finally, we need to plug in for the values x is equal to 2 and y is equal to 4. If I do this, then we get the gradient, which is a function of two variables, is equal to 4 squared times minus 1 over 2 squared, and then 1 over 2 times 2 times 4. 4, that is minus 4. I hope that is correct. It is correct. Which means, as I always like to say, that I won't have to record this once again. I don't imagine that this would be a difficult question in any sense for you anyway. But in case you didn't know what the gradient was, that was the definition. And at the relevant points, we make the relevant plugins. And once we do that, we are able to find the solution to this exercise.